Hello and welcome to my channel. This time I would like to present you template to create themes, associative themes in Catia, in this case under the 3D Experience platform, where we will have whole geometry guided by one curve and one supporting surface. We will create the theme of such shape where we can see as well that the seam itself is not lying just on top of the surface, it's actually protruding into it for more realistic appearance. We have volcano with gaps. Why we have them, how they're described, we will see that in tutorial. As well, we can see that the seam itself is squeezed in Z, so we have more realistic appearance on the shape. Additionally, you could see these black dots here, which are actually not a dot, they are a blackout surface behind, which is helping us not to see through the element when the element is open. And technically this same element could be used in order to trim together this geometry in order to, for instance, 3D print it. As well, this seam will start and end with from beginning to the end of the curve, so ending will always be applied on the end of the edge itself. It won't do some rounding or something similar. We have as well one simple example to show how this is going to be applied from our template we prepared in second and third video of this series, which then you can use exactly to create such associative themes in your models. In similar fashion, different types can be achieved, but in this case we will only take care of the one single line. What else do we want to say here is that we will start from one base element, which is one object, one single patch of it, on which lies one single seam, which has this transformed geometry so that it's not flat anymore, so that it has nice shape from all sides. If we check the supporting edges, you will see that the supporting surface consists out of three elements. The stitch itself on the bottom is open. Reason for this is tessellation and data saving, to save the data with minimal amount of on the hard drive. This as well shown that for instance seam line with 1 meter is approximately 5 megabyte heavy, so it can give you information how heavy your model at the end will be when you complete applying such template. Then how this template is created, of course we will see that in the second part, and after we create this element then we will apply it on the geometry itself, on some reference geometry that we will use to define everything, and this geometry then will support this stitch, which then we can apply this pattern exactly on this geometry. How this is done, this is then the part of the third tutorial. Here you will see as well that in references we have one separate axis system. Why is this so? We will explain that, of course, in second and third part of this tutorial. We will have as well set of parameters which then can be used to adjust the shape to respect different standard and similar. What does all these parameters mean will be described in each tutorial. Then we will as well move the relations inside by drag and drop of the relations from outside into the container. Sometimes it can happen that they are deactivated, so please reactivate them, otherwise your parametric will stop working. Of course, the structuring of the files and at the end creating of templates, the user-defined features in this case will be described based on the each part of the tutorial. So we have very similar one for the single part as we have it here for the whole line. And after we create all this, we can apply this geometry on some realistic object. In this case, we will have some default seat of motorcycle type. So, and here we want to have a seaming line all around on this surface, where part of it is presented already, so that you can see how the result looks. And here I will just show quickly how to apply it on the single element of this. So let's apply quickly this seam on this element, so that we see what properties we have afterwards and what we can modify. In this case, we have to define where we want to store it, so we can even put it in this set, defining work object. Then in template that we created in third part at the end, we'll select this user defined feature, return back to our current model, and instantiate it from selection. So we'll select the curve. Orientation of the curve will define where the beginning, where the end is. What is beginning, what is end here will be described in tutorial. And orientation of the surface has to be respected. So we have to have same orientation as is in the reference. The reference is looking inside, so we have to turn this inside as well. Technically, we could modify all these parameters on the fly directly now, but we won't do it. We will eventually change some afterwards, so we'll just confirm. After that, the additional geometry will be created, so you can see this surface is still here. The instantiation of the template won't hide it, and then we'll get in this template itself we will get a seaming line, which is in this case that yellow color. We have the supporting faces, these three faces. They are not joined for the easier transformation later, so it might happen that some of these lines has to be split additionally, but this will not be part of the scope. Still, we will leave it open, and we will have that blackout. After that, we don't even need this line anymore. These minor mistakes can always happen, depends on the curvature of your geometry and similar. The tolerances are usually relatively good, so you can cover it with 0.1 millimeter of joint so that you avoid having gaps. So you can see here, now we have a complete line all around. Here we have a couple of parameters that could be modified, so we can change, for instance, the length of the element from 4.2 on 4 millimeter. This is the length of the whole of one object, complete with gap. As well, we can modify gap from 0.5 on 0.8, and we can do other changes, or we can simply update this model. And now you will see, instead of such shape where the stitches were longer and gaps were smaller, now we have smaller elements with bigger gaps. And let's add a couple of words. What do you need in order to be able to create this? So everything here will be created with a generative shape optimizer license, or as is in 3D Experience called generative shape morphing. In V5 was generative shape optimizer. This principle for this tutorial can be used on both on V5 and 3DX. In case that you're using some older release, there were some minor differences, but I will as well try to cover those during the execution of this tutorial. So even with older releases, you can create absolutely the same result. And then I will use as well Imagine Shape to create some surfaces in order to to forward faster, but actually you can use generative shape design or whatever you want to use as an input for your surfaces, and you can see here we will have such a result where the couple of faces will be added and such structure will be generated. How exactly, why exactly, which element was created, everything will be described in tutorial. And as you can see, even this seat was built with image and shape just for this tutorial. So let's go back to shading with edges. It's smooth edges, or better to say to shading. So if you join these elements, you can apply materials on it and you can use this model for very nice renderings. On my channel you can see as well different videos with a different type of seaming, and as well there are supposed to be some realistic examples which you can see as well, which were built with more or less the same template as is shown in this tutorial. I hope you will enjoy it, and feel free to start with second part of the video where you will create this basic element.